Today's video describes the process of hydrocarbon combustion, alkyl halides, and the reactions that can be used to create alkyl halides. Recall that combustion is the reaction of a hydrocarbon with oxygen to produce carbon dioxide and water vapor. Depending on the conditions, a hydrocarbon will either undergo complete or incomplete combustion. Complete combustion gives only carbon dioxide and water as products. Incomplete combustion can also have carbon monoxide and carbon as products. Both reactions are exothermic. In all situations, both types of combustion, complete and incomplete, occur. Depending on the conditions, there may be more complete combustion or more incomplete combustion. These two equations show all of the possible products that result from each type of combustion reaction. Complete combustion is more likely to result when there is a large excess of oxygen. When excess oxygen is present, then there is a low amount of carbon monoxide and soot that would be expected to be produced. There is still some, though. Consider this candle that is in an open room with lots of oxygen. If you were to pass something through the flame, you would be likely to observe some black deposits or soot on the object. These black deposits are evidence of the incomplete combustion that is occurring. Another possible product of incomplete combustion is carbon monoxide. Carbon monoxide is a toxic gas that can be very dangerous to people if they are exposed to it in a confined area. In order to prevent carbon monoxide products in gas stoves, furnaces, or in vehicles, chemists have found that if they place some alcohol in the gasoline, then the amount of carbon monoxide emissions are reduced. This is because alcohol adds oxygen to the combustion reaction. Compare the reaction of ethane and ethanol with oxygen. See how the ethanol requires less oxygen to burn because it contains some oxygen in its molecular formula. This results in more complete combustion and therefore less carbon monoxide production. Not all organic compounds are made up of only carbon and hydrogen. Some hydrocarbon derivatives contain other elements. When organic compounds contain other elements, they are said to contain functional groups. Functional groups are characteristic arrangements of atoms within a molecule that can be used to predict chemical and physical properties of the organic compounds. Here are the different functional groups that you will be expected to remember. You have already learned about alkanes, alkenes, alkynes, and phenyl groups. Over the next week, we will be looking at more functional groups. Organic halides are organic molecules where a hydrogen has been replaced by a halogen atom. They are also sometimes called alkyl halides or halogenated hydrocarbons. In the case of organic halides, the functional group is the halogen atom that is bonded to the parent chain. Many well-known organic halides are toxic. DDT and PCBs are extremely dangerous to animals and humans. Depending on where the halogen group is located on the parent chain, organic halides may be polar or nonpolar. If the halogen is toward the center, leaving hydrocarbon ends on the parent chain, the molecule would be nonpolar. If the halide is on the end of the parent chain, the molecule would be polar. Organic halides have higher boiling points than their corresponding alkanes. They have low solubility in water, but they are more soluble than similar hydrocarbons. The naming for organic halides depends on the type of halogen that is in the functional group. The rules are the same as for regular branches on a parent chain. For this example, we start by identifying the parent chain. It has 6 carbons, so it is hexane. The chain has 2 bromine groups and 1 chlorine group, so the branches are listed in alphabetical order, similarly to how we have been naming alkyl chains. This organic halide has cyclohexane as its parent chain. Begin numbering at the bromine and continue with the lowest numbers possible. This molecule has 1 methyl group and 2 bromine groups. Branches should still be listed alphabetically. Addition is a reaction that unsaturated hydrocarbons such as alkenes or alkynes undergo to produce alkyl halides. The alkenes react with halogens to produce organic halides in the presence of a catalyst. The reactions are favorable because carbon is more stable with a solid octet and tetrahedral structure than it has when it has 4 separate bonds. Hydrogenation is also considered an addition reaction. In this case, the alkene or alkyne reacts with hydrogen to become saturated. The ability of a reaction to take place does rely on an adequate number of moles of reactants. If 1 mole of bromine is available, there would be an addition of 2 bromine atoms, 1 on each side of the double bond. If more bromine was available, then the addition reaction would yield a different product with more bromine atoms attached and a single bond. Substitution reactions can also be used to create organic halides. These reactions only occur on saturated hydrocarbons, such as alkanes and aromatic rings. The hydrogen atoms in the molecule are replaced with other atoms in the presence of light. The general reaction here shows that alkanes, or aromatics, react with the halogens in the presence of light to form organic halides. In this reaction, 1 of the hydrogens is replaced by a bromine atom. The bromine can either be attached to an end atom or a middle atom. This means that there are actually 2 different possible products. Both products are produced, but in different amounts. Although benzene is very stable, it will still undergo a substitution reaction. It can continue to undergo these reactions until all of the hydrogens are replaced with halogens. But the process is very slow and requires light and a catalyst because benzene is so stable. Well done! This is a very complex lesson with structures and reactions that will need to be remembered.